Sometimes it's beneficial to return a column of values in your results that don't actually exist in your original table. For instance, if you're building a report that you need each record to be associated with the same company, or the same tax rate to be shown along each order. Let us explore some data from different data tables in AdventureWorks database. I'm gonna scroll down until I find the production schema, and inside of there we'll find a table called product. I'll open that up so we can see different columns that make up that table. Now I wanna write a simple query that returns a few columns from this table. We'll start by pressing a new query button to open a new tab, and I'll say select name, product number from production.product. I'll execute the query, and in the results, we see data exactly as stored in the original table. Now let's suppose I want to use this data in the product catalog, but I also want to make sure that our company name is attached to each product, so that there is no confusion where these items are ordered from. I can create a new column out of thin air by adding it to the list in the select clause. I'll come up here and place my cursor after the product number and type in comma, and then the value I want to appear inside of the column. This will be retro text again, so I need a single quotation mark here, and I want the value AdventureWorks to show up here. I'll cross the single quotation mark, and that's all I need to do. Let's go ahead and execute this query now. Now we have a third column that gets the value AdventureWorks for every record that is coming out of the product table. You might notice that this column has no name, so this is a good opportunity to use an alias in the query. I'll come back here to the top and type in as manufacturer. I'll execute the query again, and now we have a better alias at the top of the column. This gives us a clearer understanding of the information that is being presented. So that's one way you can create a column of values with a select query. There is one more common use of this technique, and that involves mathematical operations. In this table, we also have a column for the list price of the item. Let's add that into our query. I'll come back here after manufacturer, and I'll type in a comma, and the next column name, which is list price. I can run this query. Then we'll see that added to the list. Now I can see that a lot of products don't actually have any price, so let's exclude those from the result. I can do that by adding any where clause. I'll move my statement terminator down to the next line and type in where the list price is greater than 0. I'll execute the query again, and we are getting some better results. So now let's say they were having a company-wide anniversary sale. I would like to create a column that displays the price of each product with the 15% discount applied to it. We can do that by adding another column to the select clause. Right after list price, I'm going to type in another comma, and I'm going to come down one more line just to give myself more room. I'll press space a couple of times to move it over. Then the next column is going to be the original list price values. And I'm going to multiply it by 0.85. Then I'll take the original list price and multiply it by 0.85 to give us the price with the 15% discount applied. We should also give this new column an alias, so I'm going to call it as sale price. I'll execute this query, and we'll see the results here in the fifth column. Now we can simultaneously see the original list price along with the price with the 15% discount. So now these results in the dataset are much more useful. We started with values that are stored in the database and expanded on them by creating a column to display manufacturer's name as well as the sales price. Neither of these columns exist anywhere in the database, and they are being calculated just for display here in the query results.